do you guys have your chromosome lab packet you could get out or with the model? Could you guys get that out for me right now? Well, it looks like this. Oh, she was in.
Can I see it?
Yeah.
I wasn't here anymore.
Oh yeah, here you go. So today we're just working on the questions. So like free right now. All right, guys, please get those out.
Sit over there.
If you guys need an extra, let me know. Okay. We're just working on the questions.
You're gonna be a what? I want to become a
Yeah. I think we started
Like, I
on
swear to
that.
God, I've been talking about it for weeks.
All right, guys. So what we're gonna be doing over the next 20 minutes is I'm gonna put you guys into 3 groups because there's not a lot of people here today. So you'll be a group, you'll be a group, you'll be a group, and you'll each answer like 1 to 2 questions. And how you'll answer them is you'll draw your answers on the whiteboard, and then you guys are gonna present your answer to the class, and then we'll talk about it. So if you got me, I'll break up assignment questions now. Could you guys do number 1 and number 3 for me? And then you guys do number 5 and number 9. You guys do number 2 and number 4. All right, and then I'll give you guys like, I don't know, maybe around 10 minutes to do that. And then again, please put your answers on these whiteboards, and the expo markers are right up here. All right, let me know if you have questions. All right, you guys presenting them and doing that real quick. So, all right, everyone, can you please put your phones down and pay attention to this? We'll do this for the next like 10, 15 minutes. But all right, we'll start with this group right here.
Okay.
Can you tell us about question number 1?
Can you read question number 1?
Question 1 is create the Venn diagram.
Here's our Venn diagram.
What's the difference?
So yeah,
The difference between mitosis and meiosis is mitosis goes into 2 daughter cells, happens in somatic cells, and prophase is shorter and then involves 1 cell division. Meiosis goes into 4 daughter cells, happens in germ cells, and occurs only in plants and animals and fungi. And their similarities is both produce new cells, start with a single parent cell, and then mitosis only results in only half of the chromosomes as meiosis because the zygote needs both mother and father. So the gametes must contain half of the chromosomes. Oh my God, I can't read my handwriting. For the body, no, for hormonal body cells. I can't read them. I'm sorry.
okay. No worries. So I just have why does mitosis end up with two daughter cells, and why does meiosis end up with 4? It has to do with how many times they divide.
This is the chromosomes split. This because they copy each other.
Yeah, so, well, mitosis, it starts off at 1 cell and divides into 2 daughter cells, right? But meiosis actually divides twice because it starts with 1 cell, divides into 2, and then from there, the 2 cells divide into 4 cells. So I would say, well, yeah, you were correct with number 3. Like, the reason why it needs to have half of the chromosomes, so like it can combine to make 1 cell with the, and then, yeah. And then one more question. Could you give me an example is a somatic cell in your body. Skin cell, yeah. Yeah, no, that's correct. So, and then meiosis, again, yeah, that just happens in the reproductive organs. Give everyone a chance to look at that. All right, great job, guys. All right, we'll go into this group. You give me the definitions for number 2. Show that off.
So somatic cells are like they make up the connective tissue of the body. So like skin cells, blood cells, muscle tissue, and like nerve cells.
Yeah, awesome.
And then germ cells are the reproductive cell of the body. So like female eggs and like sperm cells. And the centromeres are the like spinal fibers, and they basically attach to each other. And then the diploid are 2 identical set of chromosomes, and the haploid are 2 unique unpaired chromosomes. And then the zygote like fertilized eggs.
Yeah, awesome. So, just a few, do you know, so germ cells kind of a new word that, and we haven't really been using that vocabulary in this class. Like, do you know like the other word that we've been using that's kind of the same thing as a germ cell? Starts with a G too. So okay, so but then so germ cell's kind of like a gamete for that word. So yeah, not to like confuse you guys, but yeah, so gamete is pretty much the same thing as a germ cell. And then also, do you know like what type of cell is a germ cell? It's like there's a somatic cell, and then what type's the germ cell? A germ cell is haploid. Yeah, so yeah, that's correct. Yeah, germ cell only has half the chromosomes. And then, but like, there's basically 2 types of cells in your body. There's the somatic cells, which are like your body cells, where like you were saying, it's like your skin, connective tissue, muscle, things like that. But yeah, the germ cells are like your sex cells. So then, yeah, again, body cells, they're just, well, yeah, mitosis makes body cells and meiosis makes sex cells, like germ cells. And then, could you explain your answer to number 4?
So basically, the advantages is that it makes like a new set of mutation of chromosomes. So it adds variety to the cell, and the new combination of cells.
Yeah, no, that's true. But do you guys know like why do we care about that? Like, why is that a good thing?
Oh, okay. Because like animals, like organisms to adapt, and with like basically better for survival.
Yeah, no, yeah, exactly. Because yeah, so it's kind of like how I think about it. That's totally correct. But how I think about it is, let's say if you have a bunch of, I don't know, like we can just use like horses, and some of them are more adapted to slightly hotter environments, some of them are better adapted for colder environments, just based off how they were born. Then if the environment all of a sudden gets hotter, like it is now with climate change, then at least those horses will be able to survive and keep the horse population going. And then yeah, that's something that asexual reproducing organisms can't do. So yeah, no, that's a super cool thing. All right, great job, guys. All right, and let's see what the final group's got here.
Oh, okay. We
but yeah, it does do that. But I mean, I'm sure you've probably personally met someone. Like, well, what other things does it do? Does,
I'm guessing like genetic disorders.
yeah,
Maybe.
exactly. So yeah, for Down syndrome specifically, it's yeah, it has developmental disorders. They don't develop like you should. And then interestingly, I was doing some research on this earlier, and I guess anytime you add an extra chromosome, like there's tons of different disorders, genetic diseases where people like get an extra chromosome, and pretty much anytime that happens, there's like basically over a 50% chance they're gonna have a ton of heart issues too. So yeah, you can get less chromosomes, but most of the time, if you don't have a chromosome, then like you die. So like then because like if you like don't have your chromosome for your heart, like that's not gonna go super well. So pretty much all of the genetic diseases where you don't have a chromosome are on the sex chromosomes, because like the chromosomes that decide your sex, they're the only chromosomes that aren't needed for survival. So that's like, and then sometimes I did some research when we have it written down. There's like, you can get like a 2p deletion where it's just like a tiny little chunk of your number 2 chromosome is missing. And then that causes tons of issues too, like development and heart issues and a lot of that stuff. So, and then real quick, and then what chromosome, what chromosome do you have an extra of for Down syndrome? Do you know?
The 21.
Yeah, that's 21.
There's like 3 pairs with something like 20 chromosomes.
You only need like 20 chromosomes to live.
So, well, you need, so you have 46 chromosomes in total, and basically there's 23 unique ones, and then 23 are a copy of those. And you need all of those chromosomes except for your sex chromosomes to live. But except for the chromosomes that determine your gender, you need all of those to live. Because like again, yeah, it'd be pretty like, if you don't have like an organ or a leg, or I don't really know what the chromosomes all code for, but it's all important. And then one more thing I thought was interesting. So another name for Down syndrome is it's trisomy 21. In every genetic disease where you have an extra chromosome, it starts with trisomy. So like example, there's Edwards syndrome, which is an extra chromosome on an extra 18 chromosome, and that's called trisomy 18. So yeah, anytime you see the word trisomy, you know that an extra chromosome is at play there. And so, all right, good job, guys. Thanks for answering those questions. And then lastly, what did you get for number 9?
And then for number 9, there are disadvantages for asexual reproduction leading to lack of diversity, since they are exact replicas of DNA, inability to adapt, and can bring competition and overcrowding.
Yeah, no, that's awesome. So yeah, again, like we talked about over there, it's like they're not going to be able to have the genetic diversity to really deal with rapid changes in the environment. But I don't know if you saw this while you were researching it. Do you guys think of any advantages for asexual reproduction?
You don't need another partner for it.
Oh yeah, no, exactly. That takes up a lot of energy, having to go find a mate in the wild and all that stuff. Because I was watching this cool video. I forgot the exact species, but it's this crab species in Australia, and every year they have to travel like 5 or 10 miles to the beach to mate. So, and that, even though, I mean, that's a lot of distance for a crab, and that takes up a lot of energy. So, that's a big advantage. Can you think of another one?
I don't know. Just thought, like maybe the DNA, if they can't, it's consistent, like there's no changes, so there won't be. I'm trying to think, okay? Like, there won't be as many changes, so yeah, I have no idea.
No, that's okay. It's good for you guys just to like think about this stuff, even if you don't know the perfect answer, which that was great, but I kind of build off what were you saying, maybe because sexual reproduction, you have all these like genes swapping around, there might be more likelihood of like a disorder or something to go wrong in sexual reproduction than asexual reproduction is overall a simpler process. So I think you were kind of getting at that a little bit. And then one more I wanted to say is also asexual reproduction is just a lot faster. You kind of just split off and pop out, yeah. Yeah, and sexual reproduction, it's obviously not every organism, but for us, like humans and elephants and stuff like that, we have to like raise our young for years and years. Well, I'm saying the way like elephants, I mean, they raise their young and like keep watch after them. And not all animals do that, like especially not asexual reproducing organisms. They just kind of, I'm pretty sure most of them just split off and kind of just go their separate ways at that point. But, what was I gonna say? Yeah, I guess that is. Great job, guys, on your posters. And now we're just gonna go ahead and